The young clerk stares at the clock on the wall, not because he's bored, because he is imagining what would happen if he could ride alongside a beam of light leaving that clock face. Would time stop? It's a Wednesday afternoon in Bern, Switzerland, June 1905. The man at this desk, third-class examiner, patent office employee, barely making renties, about to rewrite the rules of reality itself. But here's the thing nobody tells you. He's doing this in stolen moments, between reviewing patents for improved electrical regulators and gravel in a cramped apartment where his wife does the math while the baby cries in the next room. This is the story of how a patent clerk broke physics. And nobody believed him. Albert Einstein wasn't supposed to change the world. Born in 1879 in EOM, Germany, he was the kid who didn't speak until he was 3. Teachers thought he was slow. One instructor told him directly, "You'll never amount to anything, Einstein." He hated the rigid German education system, all memorization, no questions allowed, so he asked questions anyway. What would happen if you chased a light beam? Why does a compass needle always point north even when nothing's touching it? Here's what's wild about the late 1800s. Physics was considered basically dumb. Wrapped up, Lord Kelvin, one of the era's top scientists, said there was nothing left to discover except a small clouds on the horizon. Those two clouds, they'd become relativity and quantum mechanics. And Einstein was about to unleash the storm. By 1902, he couldn't get an academic job. His thesis advisor didn't like him. His grades were fine, but not spectacular. So he ended up at the patent office in Bern, which weirdly would have been the best thing that ever happened to physics. The patent office gave Einstein something universities never would have cheated a thing. See, patent examination required him to imagine how machines would work from written descriptions. Thought experiments. The exact skill he'd need to reimagine space and time. 1905. He's 26 years old. In March, he publishes a paper explaining the photoelectric effect proving light behaves like particles. This paper alone would eventually win him the Nobel Prize, but at the time, crickets. In April, a paper on molecular dimensions, his actual PhD thesis, useful for understanding sugar solutions. Not exactly headline news. May, Brownian motion. He proves atoms actually exist by explaining why pollen grains jiggle in water. Again, the world yawns, then Juni Hitchis. He submits on the electrodynamics of moving bodies to Anellendor Physiki. 30 pages, no citations, no footnotes, just pure thought. And buried in those 30 pages, the death of absolute time. Here's what Einstein realized. You know how when you're on a train and you throw a ball forward, it moves faster relative to someone standing on the platform, okay? Now imagine that with light. Except, light doesn't work that way. Light always moves at the same speed, 186,000 miles per second, no matter how fast you're going. When you measure it, always. Which makes no sense. Unless time itself isn't constant. If light speed is fixed, and you're moving really fast, then time has to slow down for you to make the math work. Your clock literally runs slower than mine, not because it's broken, because time itself is relative to motion. This wasn't philosophy. Einstein provided the equations, but here's where it gets weird then. This is the part nobody talks about. Almost nobody understood the paper. It was too strange. The editor H. Anellendor Physiki published it because why not? It wasn't obviously wrong, but when Einstein sent copies to famous physicists, most just ignored it. Max Planck, one of the only people who got its wrote back with a question. That question led to more letters, more equations. And in September 1905, Einstein realizes something else. If you squeeze energy into matter, or release matter as energy, there's a conversion rate. A simple one, actually, E equals mc squared. Energy equals mass times the speed of light. Squared. That little squared part, that's the kick. The speed of light is huge. Square it, and you get a number so massive that even a tiny amount of matter, say, a paperclip, contains enough energy to power a city for days. Nobody knew what to do with that equation in 1905. But 40 years later, when the Manhattan Project turned it into a bomb, they'd understand perfectly. Einstein kept his day job. For 2 more years, he examined patents and wrote physics papers at night. Because even after publishing the theory of relativity, he still couldn't get a university position. When he finally did lecture in Bern, 1908, the university forgot to give him a classroom. His first lecture, held in a hallway, 3 students showed up, but the ideas were spreading slowly. Physicists started testing his predictions, and they kept being right. By 1915, Einstein had moved to Berlin, and he'd been wrestling with the problem for 8 years. Special relativity worked beautifully for objects moving in straight lines. But what about acceleration? What about gravity? Newton said gravity was a force pulling objects together. But if Einstein was right about relativity, forces that act instantly across space like Newton's gravity shouldn't exist, information can't travel faster than light. So what was gravity really? Einstein tried hundreds of approaches. The math was brutal, tensor calculus, differential geometry, stuff he barely learned. His friend Marcel Grossmann, a mathematician, helped him navigate it. The answer, when it came, was beautiful. Gravity isn't a force. It's geometry. Massive objects bend space and time around them like a bowling ball on a trampoline. Earth doesn't pull you down, you're sliding along curved space. The moon isn't being yanked by invisible string Z's, following the straightest possible path through curved space. General relativity. The equations predicted wild things. Black holes where space-time curves so much that light can't escape. The universe itself expanding or contracting. Time running slower near massive objects, meaning clocks at sea level tick slower than clocks on mountains. When Einstein published this in November 1915, even he wasn't sure anyone could test it. Then World War I ended, and in 1919, astronomer Arthur Eddington traveled to the island of Principe off Africa to photograph a solar eclipse. Why? Because Einstein's equations said the sun's mass should bend starlight passing near it. During an eclipse, you could see stars near the sun's edge and check if their positions shifted. They did exactly as predicted. Overnight, Einstein became the most famous scientist on Earth. Newspapers called him a genius. He was invited everywhere: lectures, royal dinners, movie premieres. The guy who couldn't get a university job 15 years earlier was now mobbed like a celebrity. But fame came with complications. Germany in the 1920s was unraveling hyperinflation, political chaos, and rising anti-Semitism. Einstein was Jewish. That made him a target. Right-wing physicists, yes, physicists launched a campaign against Jewish physics. They held rallies, published manifestos, called Relativity a conspiracy to undermine true German science. One Nazi sympathizer, Philipp Leonard, organized a public event in 1920 explicitly to attack Einstein. Thousands attended. Einstein sat in the audience, listening to his work being called fraud, watching colleagues stay silent. He fought back, published rebuttals, gave interviews, refused to be erased. But by 1933, when Hitler took power, the equation changed. Einstein was visiting the United States when he got word his Berlin apartment had been raided. He never returned to Germany. Einstein settled in Princeton, New Jersey. Institute for Advanced Study, quiet office, chalkboard covered in equations. He'd spend the next 20 years trying to unify gravity and electromagnetism into one theory of everything. He failed. He knew it. Meanwhile, younger physicists took his quantum work in directions he hated: probabilities, uncertainty, particles that only existed when observed. God does not play dice, he said. They play dice anyway. In 1939, he signed a letter to President Roosevelt warning that nuclear fission based on E = mc squared could create weapons of unimaginable power. The Manhattan Project began. When the bombs fell on Hiroshima and Nagasaki, Einstein was horrified. Had I known, he said later, I would have become a watchmaker. But that's hindsight talking. He didn't cause the bomb. He just described the universe honestly. What humans did with that knowledge that was unus. Mileva, Marika's first wife, the one who did math with him in that Vernapadam and died in poverty and so. Their letters suggest she helped with early papers, but we'll never know exactly how much Einstein left her. Married his cousin. The personal life was messy. The physics was immortal. Einstein died in 1955. 76 years old. Refused surgery to extend his life. He'd done his work. They found 12 pages of equations on his hospital nightstand. He was still trying to solve it. Here is what he left behind. GPS satellites, that correct for relativity every nanosecond or your maths would be miles off. Theories that predicted gravitational waves, confirmed in 2015, 100 years later. Black holes, the expanding universe, all of it. But more than that, he left behind the idea that reality is stranger than common sense. That time, space, energy, none of it works the way it feels like it should. And that's okay. You don't have to take the universe at face value. You're allowed to ask. But what if that's how a patent clerk changed everything?
Maybe.
Next time, we're covering the physicists who proved Einstein wrong about quantum mechanics and why their argument still isn't settled. If you want to see reality break one more time, you know what to do.